Hey guys, welcome to your first video tutorial in dealing with circuits. So with the circuit that I have here is one that we started in our examples. If you're wanting to see it in your book, it's on page 526. We worked out, the first question was asked, how much current is being drawn from the battery. Okay? Well, to do that, we need to figure out what my total resistance is for the circuit. In other words, what is my total R equivalence? Okay? Well, to do that, I have to imagine that these two sets of resistors are in a sense in series. So what I need to do first is figure out, okay, what's my equivalent resistance here? Since these two are in parallel, I'm going to call this resistance REQ1. And again, we did a lot of this in class today. So REQ1, 1 over that rather, is going to be 1 over 500 plus 1 over 700. And so doing that, we get an REQ1 of 290 ohms. So now, to figure out my total resistance, what I can do is simplify these two resistors down so that I end up with just something that looks like this. And so now I've got 400, and I simplified these two down to 290. So now, since these two are in series, my total resistance is just 400 plus 290. Which is 690 ohms. So that's my total resistance for the circuit. So to figure out how much current I'm drawing from the battery, I know my total voltage drop, or total potential, it's 12 volts. So I utilize the equation V equals IR, and I'm solving for R, so 12 over 690 gives me 0.0174 amps, which, I mean, most of the time we would rewrite that as 17 milliamps. So that's how much current is being drawn from the battery. Now, if this were my circuit right here, that would mean that each of those resistors is experiencing 17 milliamps of current flowing through. And so what I could do is figure out, okay, what's the voltage drop from this point to this point? In other words, if this is point A and this is point B, you have to imagine, okay, I know that I'm starting out with 12 volts, and you figure my resistance here is 400. Well, I know the current flowing through this resistor, it's 17 milliamps. And so to figure out what VAB would be, I can utilize the fact that, well, 0.0174 amps of current, and then multiply that by 400 ohms, and so that gives me a voltage of 7. So I've got a voltage of 7 going through across this resistor. Okay? Well, I can do the same thing to this 290 ohm over here. So if this were B and if this were C, I can do the same thing. So V will go BC is again 0.0174 amps times 290 ohms, which gives me 5 volts. Now, it's no coincidence that 7 plus 5 gives me 12. Okay? We're going to learn about that in the next video tutorial. That deals with Kirchhoff's rules. So now, this example's continued on, and they ask, okay, well, how much current is flowing through, they ask how much current is flowing through this 500 ohm resistor. Well, when resistors are in parallel, we've got I1 flowing up here, and then we've got another current I2 flowing here. Now, we know that I've got 17 milliamps flowing in, which means I have to have 17 milliamps flowing out. Milliamps flowing out. Which also tells me that I1 plus I2 is going to equal 17 milliamps. So what I can do is say, okay, well, I know that I've got a voltage of 5 volts flowing through, because imagine B is right here and C is right here. And then point A, we said, was right here. Again, I'm just taking this circuit because these two circuits are in a sense the same thing, and I'm just putting those points right here. So my voltage from B to C is 5 volts. So now what I'm going to do, since VBC is 5 volts, that means that I can utilize the fact that, okay, well, my resistance is 500 ohms, so I can calculate the current flowing through this 500 ohm resistor, because I can go VBC equals my I'm going to go I1 times 500. I could do the same thing, VBC I2 times 700, which we'll do here in just a second. So 5 equals I1 times 500. And so I get a current flowing through my 500 ohm resistor of 10 milliamps. Now, if you were to guess what the current flowing through the 700 ohm resistor would be, you've got 17 in and you got to have 17 out. If this is 10, this needs to be 7. We can prove that by going, again, let's box that because that's our answer that we're looking for. We can prove that by saying VBC, the voltage across this set of resistors, equals I2 times 700 ohms, because that is the current associated with that resistor. So if you plug that in, and sure enough, you would get an current flowing through that resistor of 7 milliamps. So that's the example that we see on page 527. So if we go to the next page, we have a much more complex resistor. And so a much more complex circuit. So let's look at that circuit. And let's see, we've got it says we've got a 9-volt battery, and so our EMF is 9 volts. But it also says that the battery has an internal resistance of 0.5 ohms. So I'm going to go little r equals 0.5 ohms. I gotta get better at my ohms drawing. Now, it says it's connected to the circuit shown in the figure. So let's draw the circuit real quick. We've got our battery. And what I'm going to do is I'm going to draw my 0.5 resistance right there. That's my R. And so then we go up, and we've got a kind of a branch right here. And this branch separates. And so on top of this branch, I've got 10 ohm resistance. And then the branch continues right here. And then in this branch, I've got a resistor here. But then I've also got a branch again. Ooh boy. Like this. Probably should have drawn this bigger. Here's what we're going to do. We're going to extend this out like this. Connect right here. And then lastly, we've got a resistor right there, and then bam, we're back to our battery. So here we've got positive, negative, 9 volts. And so let's fill in our values here. We've got 10 ohms, we've got 6 here, we've got 8 here, we've got 4, and then we've got 5. Okay. And so what they ask us is how much current is drawn from the battery. And then, so we want to know I. Then they ask what's the terminal voltage of the battery. So that means that they want to know, in a sense, what's the actual voltage of the battery, or terminal voltage. And then lastly, what's the current in the 6 ohm resistor? So current in 6 ohm resistor. Okay, so let's start with my total current. Okay, the actual current drawn from the battery. What I need to do is find out what is our equivalent for this whole circuit. So what do? Start small. Work with resistors that are in parallel. And you figure this resistor and this resistor are in parallel. Then you simplify that resistor down. The 6 ohm and this simplified resistor are in series. Simplify it down. These two are in parallel, and then the whole thing will be in series. So let's start small, and then we'll get more complex as we go. So I'm going to simplify the 8 ohm resistor and the 4 ohm resistor. Since they're in parallel, I'm going to call that REQ1. And so REQ1, the reciprocal of that, is 1 over 4 plus 1 over 8. And so I get an REQ1 of... Where's my calculadora? There we go. Okay. Here we go. 1 divided by, 1 divided by 4 plus 1 over 8. And then 1 divided by that. Gives me an answer of 2.66. So that is my equivalent resistance in this circuit right here. So what I can do is, imagine that I can just redraw this circuit. Hopefully I'll draw it a little better this time. So we branch like this, and so we go down and we've got our 6 ohm, and then I've got REQ1 right here. So this is my 6, and then I come up and I've got my 10 ohm resistor. These two connect, and then I've got my 5 ohm like that, and then I've got my that. Okay, so what we've done in a sense is we removed these two resistors and we simplified them down to this 2.66. And then I've got 10, 5, and then 0.5. So now I deal with the two resistors that are in series, and so those two simplify down to just 8.6. And so then what I can do is simplify those two resistors and then treat these two as if they are in parallel. So now I'm going to call simplifying this whole section REQ2. And so REQ2, again, they're in parallel, so it's 1 over. That equals 1 over 10 plus 1 over 8.6. Because again, I simplified these two resistors down because they're in series. And so doing that, you get an answer of, it looks like it's about 4.8. So REQ2 is 4.8 ohms. So now I'm just going to redraw this one more time, because now it's getting easier and easier to draw. I've got my 5 ohm, but now this whole thing has simplified down to just a resistance of 4.8. And lastly, I've got my 5 ohm resistor. So now I've got it simplified down to where I've just got 0.5 here, 4.8 there, and then 5. And since all of those are in series, I can just add them up. So I get a total resistance, or R equivalent, of 10.3 ohms. Now that I know my total resistance, I can go V equals IR and solve for my current drawn from the battery. So, doing that, let me shimmy this down a little bit. Actually, let me expand my whole screen. There we go. That looks a lot better. So, shimmying that down and plugging in my values, I've got 9 equal to I times 10.3. I get a current of 0.87 amps. So that's how much current is actually being drawn from the battery. Now, that answers, in a sense, that's part A. Part B wanted to know the terminal voltage, which you can think of as the actual voltage of the battery. Really, what they're wanting to know is, what is the voltage drop if you took that internal resistance and took it outside, if you wanted to know the voltage drop from A to B. Okay? Well, I know that my battery rating is 9 volts, and so what that would be 9 minus IR, but it would be I times my little r, times my resistance in that circuit. And so that voltage drop would give me 8.6 volts. So even though it's a 9 volt battery, 8.6 volts is what it is actually rated. Okay? That's the terminal voltage of the battery. Now, the last question asks us, what is the current flowing through the 6 ohm resistor? Okay. And so what we have to do is think about this in a sense. The total voltage around this circuit is 9 volts. Okay? So if we were to, let's go back up to our original circuit here. If we were to measure the voltage drop, let's say this is point A and this is point B. So we've got A and then B. And then we'll go B to C here. And then C to D. All of these voltage drops need to equal 9 volts. Okay? And so the voltage that I get here, and the voltage that I get here, and the voltage that I get here need to add up to 9. In other words, VAB plus VBC plus VCD need to give me 9 volts, just like the previous example that we were working. Now, I know that my current drawn from the battery is 0.87 amps. Now, if you think about it, we want the voltage from B to C. I need to know this V for this series of circuits. I want to know VBC. Okay. Well, VBC, if I just solve for this, VBC is 9 minus VAB minus VCD. Well, I know what VAB was. We just calculated that down there. It's 8.6. So what about this VCD? In other words, the voltage drop from here to here. Well, I know the current flowing through this resistor because it's the same as the current flowing through that resistor, because those resistors are in series. Okay? And it's 0.87 amps. So if I plug in my values, VBC, that equals 9 minus our VAB was, what was that, 0.86, minus, well, VCD, V equals IR. And so I can go I times my resistance, which is 5. Okay? So, doing that, let's go 9 minus 8.6 minus 0.87 times 5. That gives me negative 3.95. So, VBC negative 3.95. Okay. Now, that is my voltage drop from B to C. Okay? So, knowing that, if you think about it, these two resistors are in series, which is what we did down here. This 8.6 or 8.7, And so if you think about it, anytime resistors are in series, they've got the same amount of current flowing through them. And so what you do is combine these two resistors. Remember REQ2? It was, REQ1 here was 2.6, and we combined 6 and 2.6. And so think about it like this. We're dealing with this circuit right here, and VBC, you can think about it as negative 3.95, but I mean, it's 3.95 volts. So take that, and that equals I times my R, where R is 8.6. And so if I go 3.95 divided by 8.6, I get an answer of 0.45 or 0.4, let's go 0.46 amps. That would be the current flowing through if these two circuits were combined, this 6 and 2.6 resistor. But since those two are in series, that means they're both experiencing that 0.46 amps, which means that the 6 ohm resistor is also experiencing 0.46 amps. So that would be your current for the 6 ohm resistor. Okay? So that is a basic, not really basic, that's a pretty advanced circuitry type problem. And again, we're going to have plenty of practice on this, so don't fret if this was confusing, because believe it or not, it is confusing. Now, we're going to work, there will be another video tutorial where we work more circuit problems based from your homework. Okay? So the next video tutorial is going to deal with Kirchhoff's rules.